plenty of moisture in the air. You need something called instability, which means you need colder air above more moist air. If you get that, you get these rising currents of air through buoyancy, we call convection. And then it helps to have something to lift the air like a front. So, the other day, I think it was yesterday, we had a cold front come through. It lifts the air, and we get storms along that front. Go ahead, Tim. There's another ingredient called wind shear. And what that means is the winds change as you go up in height. So we can have light winds at the surface, strong winds aloft, and we can actually get a little bit of spin in the atmosphere due to that shear. It turns out if you couple a lot of instability with a lot of shear, you get a very severe type of thunderstorm that we'll talk about a little bit later on. Okay? So go ahead and advance through these three slides. Thunderstorms typically go through these stages. You get the towering cumulus stage, you get the growing cloud. In the mature stage, that cloud is very thick and deep. We call that a cumulonimbus. And it's producing rain in the mature stage. And then that rain-cooled air tends to choke off the updraft and the storm dissipates. So this whole cycle might just last 30 minutes or so. And this is kind of a weak shear example. Storm goes up, it rains, it comes down. Okay? Now click on this, Tim. This is actually a video. If you click on the image, it shows this process. So we've got the growing cloud. You've got rain forming within the cloud. The rain starts to fall. It cools the air. The rain-cooled air sinks and spreads out. All right? So that's the whole cycle there. The rising current of air is called an updraft. The rain-cooled sinking air is called a downdraft. And then the cold air flowing out is called outflow. All right, so those are some terms that we're going to come back to. It turns out if this rain-cooled sinking air and outflow is very strong, you can get what we call straight line winds, and we'll come back to that. So go ahead, Tim. So bottom line is, what's different about severe storms? They tend to have stronger updrafts that can support large hail, stronger downdrafts and outflows that can lead to damaging winds. And then you get a certain type of storm that's called a supercell, where the whole storm is rotating. And it turns out you can tell by looking at the storm if it has some of these characteristics. Okay? So the best thing to do is to show some examples. Here we have this cumulonimbus cloud, very thick, deep cumulonimbus cloud. This is the term for a thunderstorm type cloud. Very crisp, cauliflower type appearance, strong updraft, a flattened out area up top called an anvil. Look at this cloud down here. It's more horizontally elongated. This is actually called a shelf cloud, something that occurs due to the outflow pushing out from the storm. So there's a couple different cloud features here. Cumulonimbus, strong updraft, and then this shelf cloud feature here. Okay? Another example, again, of a cumulonimbus cloud. What to look for here. This storm has a strong updraft. How do I know that? It's got this really well-defined anvil up top. And compare the shape of this cloud to this blacksmith's anvil there. It looks fairly similar, right? This is the anvil part, the flattened part up top. Alright, so go ahead and advance one more, Tim. So strong updraft, it hits a level in the atmosphere that behaves like a lid called the tropopause, hits that level and spreads out. The stronger the updraft, the better defined the anvil cloud is. So again, see that cloud, you say it's got a strong updraft, a thunderstorm does, it may be severe. Okay? Here's another cumulonimbus cloud. We've got my anvil here, but look at this. This dome of cloud above the level of the anvil is called an overshooting top. And so what's happening here is the rising motion in the updraft is so strong, it's going above that level that we refer to as a lid. So I see this, I say, okay, that storm is probably 30, 40 miles away in this case. It's got a strong updraft, well-defined angle, overshooting top. It's likely a severe storm. Okay? Now, a lot of us weather people, we like the window seat when we fly so we can look out. And here's a case where this Weather Channel meteorologist, Stu Ostro, is seeing an overshooting top right out the window. And his first reaction is probably, that's a great overshooting top. And then, well, we're pretty close to that overshooting top. This is where the updraft is in the storm. So there's probably quite a bit of turbulence in that area. All right, so severe storms can have strong updrafts, also strong downdrafts or sinking motion, and a very strong downdraft we sometimes refer to as a downburst or a microburst if it's very concentrated and intense. So in the microburst case, you get this moist air mixing with some dry air and descending very rapidly. It drops, hits the ground, and spreads out. Think of it if I had a bucket of water, and next time I'll bring a bucket of water and do this. You just kind of turn it over, the water hits the ground, and it splatters out, right? Well, the rain-cooled air does the same thing. It sinks, hits the ground, and spreads out. Look at this picture here. It's a jet of rain-cooled air. It hits the ground, spreads out in all directions. If the storm's not moving, it'll do that. It'll spread out in all directions. If it's moving, it's going to tend to spread out more in the direction of motion. Yes?
Maybe the next slide tells us. Do we have both winds at the same time? Updraft in the center and downdraft around the perimeter?
Go ahead, one, two. In this example, well, let me answer that. It depends on the type of storm. In this supercell storm I'll talk about in a minute, you can have both at the same time. An updraft in part of the storm, and then a downdraft in another part, and they don't interfere with each other. If you go think of the last example, rising motion, it starts to rain. For a while, you have both at the same time, but eventually the downdraft overwhelms the updraft. So it just depends on the type of storm, whether you have both at the same time, or that the downdraft will kill off the updraft. Here's another picture of it. There, the downdraft is here, hits the ground, spreads out. There's a curl at the leading edge, actually. It can kind of curl back like so. So, again, this is the outflow and the outflow front. So there's a lot of terminology I'm using here. You can see it in here. There's the rain, the sinking air, and then it spreads out at the ground level. And so this is a strong wind downdraft indicator. All right, so take a look at this example.
See it? Looks like a shoe.
I've got the cloud base here. What's this heavy gray area?
Rain.
Rain. And we call that a rain shaft. All right, now get ready for some great graphics and great drawing. Okay,
So what
go ahead.
happens if it doesn't have that little swirl going on?
Oh.
It's straight down.
Go back, Tim. Go
I'm
back.
sorry.
No. Go ahead, one. Let's talk about this. I'm glad you noticed that swirl, actually. You can see it here. It's that pattern I talked about. Descends, spreads out with a little curl back at the toe. You don't always see the curl back, I think is what you're asking.
Right.
But sometimes you'll just see a deflection off to the side. Either way, it's outflow and some gusty winds. But what's interesting here is you actually see a little bit of a swirl at the toe. And sometimes this is called a rain boot or rain foot. And I like to use this elf boot example. All right, so there's your ankle, there's your toe, and just like with the elf boot, there's a little curl back. But sometimes it doesn't have that curl back to get to your question. So, okay. So what's going on here? You have the sinking air. The rain-cooled air is causing the air to come down. It hits the ground and it spreads out. And then here's the best part of this slide. Go ahead, Tim. There you go. I did that myself. So there's the curl back there. Sink, spread out, and curl back. Now what causes the sinking air? Part of it is evaporational cooling. It makes the air more dense. But also the rain itself pulls the air down through friction. So there's two factors that go into play. Take a look at this one. Take a look at this. Another really great textbook example. Rain shaft spreads out, and then there's that curl right there. All right. Now, if you were to see this, if you're driving down this country road, you might want to wait a minute, but you would actually see maybe even some rising dust in that. And you might think, is that a tornado? But it wouldn't be spinning. It would actually be curling upward and then back. I saw this myself in Montana when I lived there. And initially I saw this pillar of dust, and I thought, is this a tornado? No, it's actually outflow. Yes?
So that's rain and wind all coming down together?
It is. This is what we're seeing visually is rain. But along with that rain, you're getting sinking air. And what we're seeing here actually is more of the dust getting blown out by the wind here, and then curling back up. So, yes, there's a lot going on here. And as a spotter, you might, now that you know what to look for, you might see things like this. At the talk I was giving the other day, someone asked me about a rain bomb. What are you talking about? It was actually just a huge rain shaft, really striking. And you'll see this as you look around now, that these really dark rain shafts, and most likely you're going to have gusty winds with us. Yes?
When I lived in New Mexico, and it was large, open country, I remember you could see the storms coming. And one of the things they had told me was that, and I'm trying to remember which one is right, that as the storm was coming, you're going to feel the air being sucked in behind you going to it. And then when it arrives, it pushes the air down towards you, the wind shifts direction. Do I have that right or in the wrong order?
No, that's a great question, and I'll give you a recent example. We were working the air show, a group of us, giving them weather information, giving the pilots. And we had all these storms just north of the airfield. And so what was going on? We felt strong winds blowing into those storms, inflow winds. But when the storms dissipated, then you get outflow from there. So that's what you're describing. Sometimes you don't get that inflow effect, but yeah, two things going on. When the storms are growing, basically you get winds blowing into them. But when the outflow pushes out, then it feels a lot colder too. Have you all ever felt that? You see a storm, all of a sudden there's a big gust of wind, and it gets a lot colder. That's that outflow process. Okay. Now, you asked earlier, does it always have that curl? Here it doesn't really. Go ahead, one more, Tim. Now it's your more ordinary boot, or foot. No elf boot in this case. Rain boot. See the ankle and the toe? There's a rain shaft, and it gets deflected out near the bottom. So what is that? That's an indicator of a strong downburst, maybe some strong straight line winds. If it's very concentrated, it's actually called a microburst. Okay? All right, go ahead and toggle through these one at a time. Now, a colleague of mine over at the Fort Worth office, who now is the director of the Storm Prediction Center in Norman, he's a weather guy like we are, and so he sees something dropping from the cloud, takes some pictures. It sinks, hits the ground, and spreads out, and then dissipates. This is actually that microburst, step by step. And so this is almost like a big old water balloon. You can think of it like that. You know, a big mass of rainwater descending from the cloud base, hitting the ground and spreading out with some pretty significant winds and heavy rain. So if you were right under that, what do you think that would be like? Really cool? Now, horizontal rain. You know, how many of y'all have seen that where you get really heavy rain but it's coming sideways? Well, it could very well be something like this, a downburst with very heavy rain and high winds at the same time. So again, this is a microburst or a really intense downburst, kind of a step by step.
Are those predictable? Can you forecast those?
We can sometimes warn for these maybe 10 minutes in advance. And what are we looking for? Well, this is a big core of rain and hail, typically, but it starts well up into the storm. So the radar is looking up into the storm, right? If we see something like that start to descend, that can be our first indicator that, well, when that hits the ground, we're gonna get high winds and heavy rain. So yes, we can predict those with a short lead time.
The airport's pretty critical information.
Critical information, that's actually why those new radars were built at the airports, to try to detect these type of features. So, and there was a accident in Dallas back, I want to say, the early 80s, which was due to a microburst like this. All right, go ahead and put this into motion, Tim. We'll see, you're going to see, now watch carefully, you see the rain coming down here, watch, you're going to see a microburst.
Yeah, right there.
Did y'all see that? Now it's going to replay in slow motion. It's just raining, all of a sudden there's a more intense downward push, and you can see, all right, here's the nose of it. Can y'all see that coming down in slow motion now? All right, so you kind of, it is really like dumping a bucket of water out, right? You see this jet of rain cool air hit, spread out, and then you get high winds and heavy rain as a result. Now out west, there are some things called dry microbursts where all the rain evaporates before hitting the ground. So there's no rain, but you still get that intense wind. And so that's a whole other thing. Yes?
So the dry microburst that you were talking about, do you see a lot of dust in the air like it is rain? Because when I was coming home on 146 one day, I could see kind of close to the bridge by Hartman. It was like, okay, there's rain up there.
Yeah.
When I got there, it was dry, but it was like you could see like that, but
Right.
there was no rain.
Well, these can be very localized. So, you might get a heavy rain, heavy downpour in one area, and then a few miles away, you might miss it.
But it wasn't wet, it looked
Yeah.
like dust or something.
Right.
I could visibly see something.
That would be interesting. I'm not sure exactly what that is. Now, the dry microbursts you typically don't get around here unless it's an unusually dry day, like really low humidity. So if it were a big rain shaft, I would expect that rain to reach the ground. But you might have just missed it, or it could have been some kind of smoke or something else that got incorporated in.
Well, I have pictures of, I was going down 90 towards Devers, and like on the, I guess the north side, and there was like a rain shower, but it was really light, and I mean, it's a bright sunny day.
Yeah.
And, whenever I turned on 61, going towards, like I-10, behind me, it was like really dark by that time, but in front of me, I mean, it was like bright, bright, bright. And it never rained on me, but it was on the side of the road.
Yeah.
And you could see it, but it looked like a light rain shower, but in the pictures that I've got, it's on one side of the picture, it's like you can see the rain coming down, but
Yeah.
right next to it, it's just bright as day.
Yeah, that's what it is around here. A lot of times, really dark rain shaft here, no rain there. They can be pretty spectacular at times in the area. Go ahead to the next one. All right, here's another one. I think you'll find this interesting as well. This is out in Las Vegas, talking about a dry environment. And this is sped up in time. Now watch carefully. Wow.
Oh, wow.
So,
What kind of damage does that cause?
these winds maybe 70, 80 mile per hour. And because in Vegas, there's a whole lot of dry air to mix in with the wet moisture. So, but you can see it really is like a bucket of water hits the ground, spreads out. And we do get the microbursts around here. They're not exactly like these ones in Vegas. They're more that wet microburst type. You can get those 70, 80 mile an hour winds locally, and it can be a path of damage, but it's going to be everything blown out in one direction.
And that can be kind of a really small area, like, I'm sure I saw something like that in my yard. Just one tree, all the limbs just went straight down all of a sudden.
Right, yeah, it can be quite small. The microburst, by definition, is, I forget the size you mentioned, I think it's less than 2 to 3 miles in width. So it can be quite narrow.
So they were like when the spread on winds come out when,
Right, yeah, it basically, wherever it hits and then spreads out, you get a lot of damage. We had a case at Hobby where a hangar was completely demolished.
Wow.
But there was nothing in front of it that was damaged, and then all the debris was strewn to the south. I mean, it was over runways and everything else, and it occurred at like 11 at night. But the point is, everything gets blown out. And it's not exactly straight out, it's kind of like a bucket of water, it kind of fans out. With a tornado, you get things crisscrossed, you get some things blown the opposite way. And so it's a different damage pattern that we look for here. But it can be comparable amount of damage. Good questions. All right, next up. Go ahead, one more. It's just a repeat. All right. So, again, we're focusing now on these downdrafts, downbursts, and cloud patterns that go with it. We looked at the rain foot or the rain boot. Take a look at this cloud here. In this case, it's moving from right to left, and all this heavy rain back here, look how dark it is. The rain-cooled air is kind of wedging out into the warm, moist air, which rides up and over that wedge. So we get a sloping cloud called a shelf cloud. That's what this feature is here, a side view of a shelf cloud. Sometimes this can be quite smooth. Sometimes it can be a bit more ragged. And this is a front view from this, incredible photographer, this Riley guy. Thank you. This is more of a head-on view. So the previous one was a side view. This is more of a head-on view. You see this shelf cloud here. Look at these grooves or striations. Sometimes you'll see this as well. Now, what is this telling you? This is the leading edge of that strong outflow, some gusty winds, some rain-cooled air. It may or may not be severe, but that's what this cloud means. It's basically showing you where the outflow is. Yes. Another interesting case, picture I took as well. As I said, we support the air show. We brief them on the weather. Well, in this case, 2 years ago, this is Sunday morning. Now, they had apparently been briefed Saturday. I wasn't there. That the storms would come in Saturday night, and they did. And so as I'm walking to the briefing the next day, there's that leading edge. And look at the grooves and striations as well. This is the shelf cloud. This is the leading edge. There's some strong winds. And I'm trying to walk a little faster to get to the Coast Guard hangar up here. Okay? Here's the side view of that storm getting ready to cross Ellington Field in the air show with all kinds of tents. Nothing good's going to happen to this, right? It's not going to end well. Yeah, but this side view, again, you see that sloping cloud, shelf cloud, think gusty winds. That's the bottom line with the shelf cloud. And again, coming from left to right in this case. Okay, go ahead, Tim. And here it is on radar. Ellington, right about in here. And you see how this whole thing is kind of spilling from north to south. And I want you to notice something a little subtle here. You see this little thin line out ahead? Right there. Kind of a thin blue-green line. Yeah. You all see that? That's actually the outflow front. That's the rain-cooled air pushing out ahead of most of the rain. The rain is lagging a little bit behind it. So on this radar chart, it's this thin line that is critical for timing the wind. Call that a radar flying line. All right, Tim, so next up, here's what happened. As you'd expect, a lot of these tents were knocked over. And this is kind of a sad story here. This is a hot dog cart. Some of you are thinking ahead now. So the hot dog vendor, he was afraid of high winds, so he did not lock down his cart. He thought it could tip over. And so what happened is the high winds put that thing into motion, and the hot dog cart rolled over to this aircraft, and the canopy got caught on the propeller and created that little cut in that propeller. Now, how much do you think that damage into the cost? The estimate I was given was $500,000. So, because they had to replace this whole thing, and on that prop. So, it's just like, you don't expect, it's a consequence of the high winds. You don't think about those sort of things, but And I think the hot dog vendor was like, I'll clean this up and get out of your way. And they're like, no, that's right here. It has to be an investigation. Now, how many of y'all remember the duck boat accident that was in the news? Here's a case where we had, again, a line of storms pushed down suddenly with a lot of wind. The duck boat had set out over this lake, and it ended up capsizing. And several people died, actually. Well, look what we're looking at. Again, a fast-moving line. See that thin line again, right here? In fact, in some areas, there's not much rain behind it. This is that outflow boundary with gust of wind. And if you listen to the captain, he was like, well, yeah, it just came out of nowhere, without warning, had no idea. But the weather office actually put out a severe thunderstorm warning for winds about 30 minutes prior. So that was a very, very sad story. But it's another example of this type of outflow and gust of winds. Go ahead, Tim. So, we've kind of covered a lot of ground here. We talked about updraft, downburst, outflow, straight line wind damage. Let's talk now about these supercell storms, these rotating storms that are especially severe. What do these look like? You've got your overshooting top, your anvil. At low levels, you've got your wall cloud and tornado with this type of storm. Now in our area, you don't often see all this kind of detail because of all the moisture in the air, all the rain that gets incorporated in. There's a version of this type of storm called a high precipitation supercell, and I'll show you that in a little bit where things look a little different. Okay. Here's just another cartoon example. Overshooting top, anvil. I didn't talk about mammatus clouds. There's a certain cloud pattern where you get these little dips at the base of the anvil, almost like little cups coming down, and those are called mammatus clouds. Here, the cumulonimbus, the wall cloud, the tornado, the rain on the right-hand side, the storm moving from left to right, and a little bit of a shelf cloud, again, where the outflow is pushing away from this supercell storm. Okay? All right, so here's a real example. I'm looking at this thing. You may be talking about earlier about inflow winds. The winds are blowing at my back into the wall cloud area. The wall cloud is where the air is rising into the supercell. And then here's my heavy rain and downdraft on the right-hand side. In this, for a supercell, the updraft and the downdraft don't interfere with each other. They coexist, again, because of the wind shear that they form in. So this is an especially severe type of storm. Good example of the wall cloud. Air is rising into this part of the storm, so you typically don't see rain coming out of it. The rising air is too strong. It falls in a different part of the storm. Okay. Another kind of impressive looking storm, right? It's got the updraft here, the underside of the anvil. These grooves there are called striations. And so sometimes the supercells will have these grooves in them as well. Remember, the whole storm is rotating with the supercell. So I was given a talk one time, and the other presenter talked about the fanning out at the bottom being analogous to, a woman in a dress kind of spinning, kind of fans out. And so you can actually see that there. And then look at all this heavy rain, pitch black on the right-hand side. Storm moving from left to right. This one doesn't really have a well-defined wall cloud, but if it did, it would be kind of in this area. Okay? All right, this is what we call an SLC, a scary-looking cloud. It's scary, all right? And what are these? Striations, right. Yeah, I've mentioned it a few times. You guys are picking up on it. It almost looks like a screw head. As soon as I see this, I say, that's a supercell. That's a scary-looking cloud. And
thought was tornado.
And these are the types of storms that give you tornadoes, the largest of the large hail. That's why the supercells are so important to recognize. So In this case, you see a bit of a rain or even hail shaft there, but they can produce tornadoes for sure. Okay? Let's focus on the wall cloud part of the storm. You can see this lowering here of the cloud base. This is where the air rises up into the supercell. Sometimes this whole thing may be turning slowly or rotating. And again, this is an indicator of a supercell. Now there are lookalikes where this cloud area is detached. If it's detached, it's not a wall cloud. Sorry. So the air is rising up, really well defined. This is almost on the ground. So go ahead. Another example of a wall cloud. Again, it's attached, and the rising current air, the updraft is coming up into the storm through the wall cloud. You might even be able to see these little cloud fragments rising into the wall cloud if you were to see this in motion. So this is probably the most complex thing on your sheet to report to us, wall cloud or rotating. All right, now we're going to put this into motion. I want you to focus on this lowering of the cloud base here. See if you can make out any rotation. So go ahead and. All right, now this is not sped up. This is more real time. So look at. Can you see any kind of turning? Yeah. Yeah. So as a spotter, you might have to actually study it for a minute or so. You know, is that lowering actually spinning? And then you can call it in as a rotating lowering or rotating wall cloud. So in a minute, we're going to speed it up and you'll see it more clearly.
Oh, wow.
See, there's some of that scud rising up in. This can be a precursor to a tornado, and it certainly is an indicator of a supercell storm. So that's why we ask you all to call something like this in. All right, another video. Go ahead and let it roll, Tim. Pretty spectacular video here. You can see dust storm there. Now, if you see this on YouTube, it's got dramatic music and all kinds of. And you're going to see a lot of things we've talked about: rotation of the storm, striations, outflow.
You're fine. They are using it.
There's your rain area here. Now, watch the formation of a wall cloud here. It's the rain moistened air is going to feed back up in the updraft right there, and you'll get a wall cloud form. That's really what the wall cloud is. See it there? You see you can actually see the rain air feeding back into the updraft. Now you'll see a little bit of almost like a little bit of a tornado trying to form there. You see the outflow with the dust. The whole thing has striations spinning around this supercell storm. Sometimes you'll hear of an inflow tail. That's what that cloud feature is there. Okay, Tim, go ahead and bounce it up ahead one. Now, you don't see all that every day, right? And it's hard to see all that detail here. That was a West Texas case. Go back, Tim. Just go back. Don't click on that yet. Yeah, leave it there for now. And so the reason we don't see all that detail, in part because we have all the moisture and all the rain wrapped around. But that's a West Texas supercell that we saw in the previous video. Now in this case, this is a nurse heading home from work. She takes this picture. Look at this low-hanging cloud here. What does this look like to us a little bit? A wall cloud. Yes, indeed. A lowering of the cloud base. And Tim, go ahead and click on this side, and you'll see what this produced. This is up on the Grand Parkway, and there's a couple things going on here. You've got the tornado, and you've got the traffic. One of these cars is going the wrong way. Now, tell me which car is going the wrong way. Yeah, there's one going slowly towards, there's one hightailing out of there going the wrong way traffic-wise, saying, I'm out of here. So it turned out this one did not do much damage at all. I mean, I surveyed this. There was some pine needles, some limbs down. So fortunately, this was an EF0 tornado. But again, came out of a supercell storm with a wall cloud.
I'm still confused on how people just drive dirt on. I don't know that I want to.
Yeah, I'm with you. I can relate to people that are pulling over and kind of trying to figure out the course of action, but a lot of people are just more or less oblivious, even if it's right
Almost
there.
like they're more into taking the video than they are into anything that's going on around them.
You do see that, a lot of video out there from storm chasers that get way too close, and I think they're almost like in a trance, by this thing in front of them, so it's very dangerous.
I drive a lot, and I see a lot of people do that kind of stuff, and I've never understood it, and I know they're not all storm chasers, so,
Right, no,
you know?
and they're not looking at the road either, right, so you kind of worry about that,